Good morning, everyone. My name is Rachel Idadukunda. I'm going to take you through my first assignment of statistical machine learning. So I have 4 questions, 3 questions collapse, and the last question is bonus question. So among those 4 questions, I'm going to take you through the first exercise or first question, which is very important. So we ask you to apply the 9 rules on any data set. Those 9 rules, they are the rules that used in statistical machine learning. So with my problem or my exercise, I choose to use data set called Pima India dataset. So this Pima India dataset has 9 variables which contain the features and the output. So the output is the diabetes status. If the patient has diabetes, we predict 1. If patient has no diabetes, we predict 0. So the rule number 1 is how you create or the formulation of the problem. As I said, formulate this as a binary classification problem. So this will predict 0 and 1. This is binary classification. So this dataset have 8 variables, as I said, 8 features. This is the way we predict the probability if you have a diabetes. So the number 2, it is about the data correction. This shows how the data corrected. As you see, as I said, you have 9 variables. The last one is diabetes. Predict positive or negative you have, or if not. So on this rule number 2, we have the correlation. As you see, we have a certain correlation between binary type and the glucose. Binary type is the same as diabetes or not, and also the pregnant and the age, and also glucose with this one, you saw it. So this we are going to focus on rule number 3. This is called the hypothesis space or function space. So among this hypothesis space, we choose to use the logistic regression in our model as our main model. So this is how we use to calculate the binary type if you have diabetes or not using this logistic regression model. This is, as I said, we depend on the probability, which is equal to the model. So this logistic regression is good fits for binary classification because it is able to predict 0 and 1. That's why we use this logistic regression, and also it makes model easy to analyze and also to make the prediction or to estimate the parameters of the model. In rule number 4, it is the principle of learning. This one, it is where we train and we test. Here we train to minimize the loss or the probability of getting diabetes at high level. Here we apply logistic regression or maximum likelihood method. So this is the maximum likelihood method we applied on it. So this rule number 2 helps to show the model by rewarding the good prediction, by showing the good prediction, if it's good or if it's not. And also we can compare them by using a call on LOC or AUC. In number 2, it is the algorithmic. For here on algorithmic, after fitting the logistical model, we use gradient-based method. This is the gradient-based method. You see this, the derivative. That's the derivative of Ross function. It is the same as the gradient of Ross function. So the objective of this one is to minimize and standardize the features. So rule number 6 is the regression and define. This is how to reduce the overfitting. This reduce overfitting, we use regularization, where we calculate the parameters, regularization of parameters using this formula. As you see, this is the parameter lambda. This parameter lambda shows how we penalize the large coefficient. We select the best value by using this lambda. At number 7, it is where we can compare the method, the different method, and also we can predict which is the best method among this data set. So for here, I used regression, KNN, sorry, and decision tree. As you see on this graph, decision tree is in a blue color, statistical, logistic regression in late, and the KNN in green. As you see, this one, we use AUC to choose which is the best model, as I said above. So as you see, among those three methods, the logistic regression is the best one, which has the highest AUC. And we know that if the model has highest AUC, the method we used will be the best. Even if this one has high AUC, but is very low compared to logistic regression. That's how you conclude logistic regression is better for this data set. So at tree number 8, this is where we show the statistical inferences and the theory. So here we understand the features or the independent variable and also find its parameters. After finding the parameters, we compute the variance and also the confidence interval. We calculate it by using this formula. This W is diagonal matrix with the height. So this one among the all variables are things we have seen that this equals the part of features which can cause to have diabetes. So that's why I used an example that we can plot it, because as the glucose increase, the probability of getting diabetes also increase. So at tree number 9, this is where we develop the practical, show how the model has been practiced. So this one, as I said, we have 8 variables. This is the probability of getting diabetes and also probability of getting non-diabetes. This also can help us at clinical support. So the doctors or nurse can use it to predict or to show that this one has diabetes among the given features. So the logistic regression is easy to deploy. It makes suitable for both clinical applications, and also this model can be understood. It's very to understand the concept of this model. So thank you for watching my video. Thank you so much, guys. Thank you for everything.